Okay, I've given everybody the customary 3 minutes, so I think we'll crack on. Um, Welcome everybody to another session as part of the Global Hackathon 2020. It's my absolute pleasure to introduce Sunil and Abhishek to you all this morning. We're going to cover kind of an introduction to AI. But first off, kind of a quick update on the hackathon itself, really. So we've had just tremendous response from pretty much every business unit across Maersk. We need to do a little bit of digging to find out if we've really missed anybody, but we've got over 400 participants now. We've got over 200 teams taking part in the hackathon. This is a global massive initiative now, and we're as the kind of organizing committee, we are absolutely bowled over with the response. So thank you to all of you who are making this happen. Quick reminder to everybody, of course, it's the 17th today and it's the 20th on Friday. And 20th is the submission deadline. So if you haven't started working on your submission yet, please crack on. Ask for advice, ask for help and support. We have loads of strategic vendors waiting to help us. We can help you to form an awesome submission. So we've got Sunil and Abhishek here. Both are super established in terms of artificial intelligence. Sunil sent me this kind of massive bio of all these things, and it's very impressive. It makes me feel very stupid. He's got a PhD in machine learning, natural language processing, with prestigious 40 under 40 data scientists in India. Lots of awards by Analytics India magazine, absolutely amazing. Abhishek joined Maersk 1.5 years ago. Before joining Maersk, spearheaded efforts as a data science tech lead with AI Center of Excellence for companies like IBM Research, Visa, Fidelity, Dell, and Genpact. Research interests, publishing 5 research papers, 3 patents, 4 trade secrets. Like this, we are joined today by people that really know this craft. So I'll stop talking because you're not here to listen to me and hand it over to Sunil and Abhishek.
Dave, thank you so much. That was an overwhelming introduction. So I'm all flattered here. Yeah, thank you everyone for joining the call today. And we belong to a team called IDA. It's Innovation and Digital Automation, which is under Order Handling Platform under Regression. So when we say innovation, we primarily innovate through AI methods. And so far in the last 1.5 years of the team's inception, we were able to do about 3 patents. We are going with the 4th patent at the moment with Maersk. So some good things are happening in this landscape, and AI being the most talked item, we thought we will do this session to introduce what is possible with AI, and also to introduce you to various techniques that is available in this particular landscape, and how is that you can easily accomplish AI. I mean, even if you're a non-coder, how can you get AI integrated into your hackathon project, or even in your work, how can you go about getting that? So those are the things I wanted to cover in today's session. This is not going to be a overwhelming lecture. I don't want to get you to a lot of mathematics that is involved, but I wanted to introduce you to various components that are possible with ML and AI, tell you certain use cases, what is possible with these elements to be accomplished. And also I'll talk about a couple of tools, and possibly I'll show you online how to access these tools and go about using them. So that's the brief agenda. My co-host Abhishek will also be intervening in between, just in case I mess up explaining something in a good way. And of course, you're encouraged to ask a lot of questions. Please feel free to intervene in between and then ask questions just in case you have any. Right, so what is ML primarily used for? So that's a question that I get very often from people when I talk to them. So ML is used for multiple things. So primarily, it's used for fortune telling, right? To be very precise, right? So basically, the reason we go to fortune teller is to understand your future or predict your future. So that's exactly what we do in ML also. And prediction of future means multiple things, right? Whether I will be successful in life or not is a yes or no question. So obviously that kind of a question is called as classification, because I fall into one of the buckets called yes or no. There it is about bucketing you into one of the possible buckets, whereas regression is about predicting a number. So something like, I wanted to understand what will be the salary that I'll be earning next year, right? Or what will be my total compensation next year, given that I've been getting a X percentage of hike year on year, right? So, or I was just given some data and I was asked to identify inherent groups inside these data inside the data that was given to me. So that's called clustering. So we will talk about each one of these items. So Dave, would you mind muting everybody? There's a lot of background noise for some reason.
Absolutely, no problem.
Thank you. All right, so these are the various things, the one that you see on the screen are the various things. We will talk about each one of them in detail. So these are the various possible ML elements that you could include into your projects, whether it's for hackathon or for your daily work in your in your offices, right? So regression basically means I wanted to predict a number, right? So it could be what is the cost of a particular house, or how much this particular shipment is going to cost me, etc. Right? So here precisely, I am predicting a number, right? So that is when we call that particular thing as regression. Of course, there is not a single algorithm that can accomplish it. There are lots and lots of algorithms. Linear regression is the most common algorithm that you would hear. And I'm not getting into a lot of mathematics behind how regression is done in this particular session. But if I want to predict, what is the life expectancy of this individual, how much time he is going to stay in the organization, or if I wanted to understand how many resources are required for execution of a project, all of this basically means I am predicting a number, and that's when I would be using a technique called regression. Right. So let's go on to another technique called classification in ML, which essentially means I wanted to understand if it is going to be falling under a bucket called X or bucket called Y. So it could be a shipper. When as a shipping agency, I basically receive the manifest, and in the documentation, I see a particular kind of goods declaration by the customer. I wanted to understand if it is a dangerous good or a non-dangerous good, right? So again, it falls under one of the categories, right? Out of the total possible categories, right? Like dangerous good or non-dangerous good. So prediction of the category of that particular shipment is called as classification. Again, there are multiple kinds of classification. Say, for example, if you take a movie genre, right? What does this particular movie belong to? It can belong to tragedy genre, or it can belong to funny genre, or it could belong to romantic genre, etc., etc. So the only difference is, unlike whether I belong there or whether I belong here, in this particular genre classification, you have multiple genres assigned to the same movie, right? At the same movie, a movie called Titanic, it's a fun movie. It's a movie about accident of a ship, etc., etc. Right? So it's multiple genres that can be assigned. So there is classification that can be done in order to assign only one class to a particular incident, or it is also possible that I assign multiple labels to the same record. So all of them fall under a group called classification as such. The next one is, so for example, you have a dump of data.
We have a hand up from Mun. You've got a question, Mun?
Yep, sure. Go ahead, please. All right, go ahead. Please ask your question.
Go ahead, Mun. Or not. Carry on, Sunil.
Sure, that's a false alarm, maybe. Okay. So let's assume that you have a group of when you were given a set of data, and I wanted to understand how many sets of customer types are there in that particular data. So even Maersk has groups of customers, right? So we have 7 different groups of customers. So how do a marketing team come up with these kind of inherent groups given data? So, or I have issues that are logged on the ServiceNow tool, and I wanted to understand how many types of issues are coming on a weekly basis, or what are the various broad type of issues that are coming in. So now, instead of actually having a fixed group of classes, here I'm just passing in the data to the algorithm, and I'm asking the algorithm to identify the groups that exist within the data based on the characteristics of the data. So, for example, we could actually divide all of us that joined this particular call based on which office location do we work from. So all the people that work from Bangalore will be put into one group, and then all the people that work out of Denmark will be Denmark office will be put into another group. So the algorithm inherently will come up with such kind of groups based on the characteristics that we have in the data. So here we don't have predefined classes. We don't have any pre-established mechanism in terms of saying, okay, these are the possible classes. So that's the primary difference between clustering and classification. So in classification, we have predefined groups. So whether it's a dangerous good or a non-dangerous good, I already know there are 2 kinds of groups in the data. Whereas here, I don't have any such discrimination. All that I have is just the data. Based on the data, I wanted to be able to identify the groups in the data, right? So that's when I employ something called clustering. Anomaly detection, right? So for example, there's an outlier. I wanted to identify outlier in the data, right? What is an outlier? Anything that is 2 standard deviations or 3 standard deviations away from the mean. Statistically, that is what called as outlier, right? So for example, average age of all the employees in Maersk is about 40, right? That's the mean age of all the employees that are working here. However, I see one person's age is 92. Definitely is an outlier. Or there is one individual employee that has an age of 13, so which is far away from the mean, right? It's like 1 or 2 standard deviations away from mean. So obviously it's an outlier. So outliers need not be numbers. It could be a defective part in a ship, or it could be a cargo that's not normal, right? So for example, you're swiping your credit card, and there is an unusual transaction that was observed by the credit card company. Say, for example, I have a practice of swiping my card for Indian rupee transaction. Suddenly, my credit card company observed that I transacted in American dollars. So this is an outlier. So this kind of trapping such kind of a outlier behavior is what is done in something called anomaly detection. And the example that I gave you just now is a fraud detection example. And there are a lot of products for that matter in this area. So one of the companies that I worked for, FICO, they had a product called Falcon and Hunter, which were primarily targeted towards identifying such fraudulent transactions or potential fraudulent transactions. And they employ very heavily ML techniques behind these products that are there in the fraud detection area, right? So similarly, we have recommender systems. When we go to Amazon or when we go to one of the e-commerce site, you see when a particular product is bought, it always says the person that bought this also bought this, right? So obviously, how is this recommendation done? This recommendation is not random. Rather, it is based on the historical transactions that happened on the e-commerce site, right? So for example, I bought a OnePlus 7 mobile, and there are associated products with OnePlus 7 mobile, such as a phone cover or such as a screen guard, etc., etc. This is what other people similar to me have bought on Amazon when they bought a OnePlus 7 phone. Again, this is an ML technique. Recommender system is an ML algorithm that mines all the transactions that involve the 1+7 phone, and it tries to identify what other products were bought along with 1+7. Right. So that is one example of recommender system. Similarly, when you go to a newspaper, right, a new online newspaper, or even if you go and search for a particular movie on Netflix or Amazon Prime, etc., when you search for a movie called Titanic, the other movie that gets recommended to me is Poseidon, right, which is also a movie about a ship accident on the ocean, right? So how is that the system is automatically detecting, you know, detecting that Titanic and Poseidon are very similar movies. So that's again the power of recommender system. So similarly, based on your interest, YouTube automatically suggesting the kind of music that you like, movies that you like, and how is that it is coming up with these kind of recommendations. Again, it is because of ML algorithms that are of recommender system category that are functioning in the background. And for that matter, right? So even in Maersk, we see a use case, a potential use case when a particular person or a freight forwarder comes to Maersk.com and tries to book a particular shipment. We could possibly recommend to him the products that are of interest to him based on the historical transactions that he has done, based on what other people like him have purchased along with just booking cargo with us. So this is one of the potential use cases that we see in the recommender system area in our own shipping domain. Right. Similarly, you have forecasting, right? So I wanted to be able to predict when is that this particular freight forwarder is going to book with us next, right? So it's a time bound activity, right? So there are seasonal patterns. Say banana shipment from Africa will happen during certain time, and the exports and imports in India, they peak at a particular time. So here also you're predicting the number. When is that this particular customer is going to ship next? Is again predicting a number, or how much volume is going to predict in the month of March 2021 is also predicting a number. However, there is a time element associated with it. So when you do a regression, you're just predicting a number irrespective of the time. However, in forecasting or time series forecasting to be precise, you are going to predict a number that is associated with the time. So the difference is the same shipper, if it is January, the volume of shipments he would do is different, whereas in the month of March, the volume of shipment he does is different. If you apply a principle or a technique called regression, you're going to purely predict one number for the entire year. Whereas if you apply time series forecasting, it is possible that you predict several different numbers throughout the year. So which essentially is time bound activity, right? So and that reflects more of a truth rather than regression, right? So that's the primary difference between regression and forecasting. Okay, finally, and then we have something even more powerful called natural language processing, right? We think data is in the form of table, right? But if you actually think a little bit more, you'll understand that data is in the form of emails, data is in the form of chat transcripts, data is there in your contract documents, data is there in SOPs that were written to have our processes running. Data is there in our knowledge bases, right? And at the same time, data is also there in images, even in photographs. There is data. Say, for example, if you go onto Facebook, it automatically is tagging your picture as these are the people that are located in the picture. So there is data in there, and when you actually have a photograph, there are numbers in it, there are street signs in it, etc., etc., right? So and then even in the speech that even in the talk that I'm giving, right? So the speech signal also has some data in it. So data need not be in a structured format. Data can be in unstructured format as well, such as text documents, such as speech signals, such as images, such as video files, etc., etc. All of this need to be mined in order to get information. And unfortunately, the so-called regression classification techniques are not capable of um, are not capable of identifying information from the data that is in unstructured format, and that is where we would have to apply advanced techniques. Specifically, when you have text documents, you have to apply techniques such as uh, natural language processing. So this morning I was having a call with Simon, and he had a very unique challenge. They wanted to be able to identify what are the root causes for several issues that are popping up on ServiceNow. Again, what they have to use there is a broad umbrella of techniques called natural language processing. Or if there is a Gallup survey, I mean, recently we had our employee engagement survey, right? So forget about the ratings that we have given for our managers and the organization, etc. What if I were to just mind the comments that people have put in, understand what sentiments they are reflecting? Are they happy? Are they sad? Are they neutral against the company's policies and the changes that are happening? All of this can be done through natural language processing. I mean, we had elections in the US, right? So in fact, one of the things that were one of the analysis that was done through natural language processing is the speeches of Joe Biden and speeches of Trump were taken as input, and it was analyzed to identify technically who is more empathetic, who is actually speaking the truth, who has more emotions, and who has more compassion towards people. So such kind of great things can also be done through natural language processing as such. And similarly, I'm sure you would have heard about flying cars and self-driving cars and automatically being able to identify number plates, automatically being able to understand if there what is the damage of a car, if at all there is an accident that is involved with the car, etc. Right? So all of these techniques come under a category called computer vision. Right? Say, for example, um, you go onto Facebook, and if you put your picture of yourself and your friends, it's automatically putting a bounded box on your faces, and then it is tagging that this person is Sunil, this person's Abhishek, this person's Dave, etc. How is that happening? That's actually happening because of machine learning techniques, specifically computer vision algorithms that are available there. And how can we actually leverage all of this broad areas, right? One is you could develop all of this from scratch. So for that, you have to be an expert data scientist. You might have to use languages like Python, R, etc., etc. But not everybody comes with a formal education in machine learning and natural language processing, right? So some people are business, some people come from math background, some people come from psychology, etc., or technology background, etc. Right? So, but the good thing is AI is getting commoditized very heavily, right? Earlier on, when I used to study AI/ML formally in university, this was a strongly guarded secret among group of PhD people. So even if you have to learn a technique, you need to have a strong relationship with your mentor, and only then he will give that discourse. And it's very heavily mathematical in nature, so it used to be very difficult to understand what happens in an algorithm, etc. But the recent phenomena is that AI is getting commoditized very heavily. So which essentially means we wanted to make it available to normal people like us, right? We wanted to be able to make it easy for people, even in business area, and we wanted to encourage people to use it for their regular tasks. One such example is our own humble Excel, Microsoft Excel. They have tons and which are machine learning related today inside MS Excel. In fact, they have bought revolutionary R, which is a primary machine learning language, and they're now embedding R programming into Excel itself. So if you have data in Excel, you don't have to go anywhere, click, click, click. It is automatically going to build a machine learning model for you. In fact, the trend analysis, the so-called linear regression that I've spoken initially on my slides, the so-called time series forecasting, all of them can be done today without even thinking a lot about programming, without even thinking a lot about AI. You don't have to know, of course, what is happening internally, but the forecast function that is there in Excel today helps you to basically build a time series forecasting model, which is similar to what we would otherwise build in Python, right? Similarly, you have Azure ML Studio. All that you have to do is just click, drag and drop, right? As long as you're able to do that. I'm going to use Google just to introduce you to a couple of tools, how you can actually do machine learning without a lot of code.
Neil, just before as you do that, let's take a couple of questions from the group. And I can hear
Yes.
we've got an extra little
Yes.
speaker in the background, which sounds super cute. So a couple of questions here. First one from Anita, quite fascinating. We'll be curious to know of any current AI application that is launched or about to launch within Maersk.
Oh yeah, yeah. So we have built several applications. Abhishek, it's you who is actually driving all of these projects within the team. It's more relevant if you could represent your work. You want to talk about it?
Yeah, sure, Sunil. So, Anita, there are a lot of use cases that we have worked on. In interest of time, I'll just highlight few of them. One particular use case we have worked where there was unstructured text available whenever we are getting any kind of booking amendment related details, and the task at hand was to identify what are the different changes that a customer is requesting. Because the nature of the data is it was in the form of text which was unstructured, we wanted to identify what are those particular changes, whether it is related to the container size change, it is related to the port change, or it is related to the estimated time of delivery or something else. So we applied NLP model here. We extracted those details and tried to provide them into downstream application. So this could be a touchless process. Automatically booking amendments can be handled using this kind of NLP and AI based engine at the core. So that is one project that we have worked on. Other things we have worked were related to one of the forecast project we have done, and one more thing where again in the information extraction side we have worked on the PDFs. So suppose if there is some remittance or proof of payment request coming from customer, we can automatically extract this information from the PDFs, which can be in the form of image files or text files, and we can validate it without any human intervention. So these are the few cases. We definitely have worked on other stuff as well, but in interest of time, I just want to give you a snippet of that.
Thank you. A technical question here. How feasible is it to use packages like scikit-learn or Carrot for production code?
Sure. So of course we use all of these packages: scikit-learn, pandas, numpy. All of these libraries are bread and butter for us. And of course, PyCarrot is one of the recent libraries that is available in Python to build and choose the best machine learning model for the given data set. And Carrot package is one of the popular packages with R in order to do several tasks like training and testing of the models. And these are common things that we do every day.
Awesome, thank you. Cynthia has asked, would you please share the demo or the link of the recommender product and computer vision, especially in the implementation for application for damage container inspection? Thank you.
Yeah, so damage container inspection was one of the use cases that actually came to us for prototyping. We haven't implemented it yet, but it's not prioritized yet by the QED team, but it's a potential project that we can do with computer vision. In fact, Cynthia, I'm going to show you how you can implement computer vision models even without a single line of code in a couple of minutes. So you don't have to know OpenCV or anything for that. I mean, it's there are tools available where you could implement it with a button click, as long as you have the data.
That makes sense. Okay, we've just got a couple of questions. So Sigata has asked, for reporting purposes from ERP, specifically in SAP, is it possible to read the SAP tables and fetch all the information the user wants along with the data available in all of the integrated systems? If yes, how do I start?
Sure. That's a good question. In fact, I'm going to be talking about how to deploy your machine learning model in a couple of minutes, and that should give you an answer precisely for it. So just wait for it. In a couple of slides, I'm going to talk about it.
Perfect. Nick, I'll come to you separately on how to get connected with kind of mentors and coaches as part of the hackathon. So actually, could you send me a direct Teams message, and then I'll respond to that after this session. And the last one, Huzefa, sorry if I pronounced your name wrong, very insightful. So can this ML AI be used to leverage market analysis and of the customer business that will assist in better sales?
Yes, that's one of the popular use cases, right? So market analysis and identifying potential customer groups, rolling out customer campaigns, identifying churn rate, all of these are marketing use cases and very well be done with machine learning and associated analytics as such.
Awesome. Kamal, you've put your hand up. Do you want to ask your question? No. Okay. Crack on, Sunil. We'll take some questions near at the end.
Super. All right. So on the screen, you were actually seeing how ML Azure Studio model is built, right? So on the left-hand side, you have several options, and you are going to drag and drop these options. And this is what actually creates a machine learning model for us. I mean, in fact, it's not that Python can be daunting, right? So you have to write code in order to build a machine learning model in Python or R or very similar languages like this, Scala, Julia, etc. But if you're a business person and you really don't know how to code, or you don't have that interest in learning the code, then these are tools that you can leverage, like Microsoft Azure Machine Learning Studio. So here it's a drag and drop interface. You could just say, all that I'm saying is, I have this data set that is loaded, drag it, and then I'm saying select the subset of columns. And if there is missing data, go ahead and clean the missing data, split the data. And then we are saying that use an algorithm called decision tree forest, two-class decision forest, and then tune the machine learning parameters, I mean, model parameters, train the model, score the model, evaluate the model. So this is it, right? So this is what we would otherwise do in the code as well. However, because these corporate companies have thought about commoditizing it, they have come up with easier tools which you could leverage. In fact, once I build this model, right, the model, after the train model, I'll have that model object that I could directly deploy it onto Salesforce or SFDC or any kind of a system, and then use it to score the records that are there in those systems as well. I'll be talking about how to deploy it in a couple of minutes. This might sound really crazy and amazing for you, but try it. You will find it absolutely easy, right? So one of the reasons AI has been a shied away area all this while is because people have kept it as a secret and then people have portrayed it as an area which is extremely difficult. But it's not, especially because it is now getting commoditized. In fact, there is this open source tool called Weka, which I have used for my my PhD projects, right? So the tool looks like this. You can install it on your system, and then you can go ahead and design your own machine learning model here without even writing a single line of code. So the whole workflow looks like this, right? You can see you can design a workflow by just dragging and dropping. All the elements are here, all the elements which are required to build a machine learning model are here on the left hand side. All that you'll have to do is configure the system such that it is going to build the machine learning model and do the pipeline for you, right? So data engineering and science, everything is done here with button click. Similarly, it's not the only tool. There are lots of tools like this. H2O is another tool where, again, you could actually go ahead and build your own machine learning model without having to think a lot about coding. So again, there is a commercial version. There is also non-commercial version of this particular tool. Non-commercial version is absolutely free, and you could use it for our hackathon purposes also. right? So you can see the tagline there, democratizing AI. And here you can do very powerful models. You can do a lot of analysis on the data without having to code anything. So if code is the one that is actually refraining you from getting into this area, nothing to worry about. In fact, somebody asked me about customer churn and marketing areas, right? So you can see propensity of leads. They have templates already, right? They have pre-built machine learning models already. You could actually take them and then use them for your own purposes. In fact, in digital marketing, you wanted to do marketing campaign analysis. Yeah, there is a template already, right? You don't have to do anything. So it's just going and reusing that particular model, right? Similarly, if you have to build a face recognition model or voice recognition model, music recognition model, here it is. Even post detection you can do without a single line of code. Google has open sourced this particular machine learning model commodity page called Teachable Machines with Google, right? You go to this particular site. Actually, my son is 7 years old, and he actually uses this site to build his own machine learning models. So all that is required is you gather the training data, and then you train the machine learning model with a button click and export your project. You just go to this site. I bet you can build a machine learning model right today, right? Without having to think a lot. You could build your own machine learning model for all of this tasks: sounds recognition, poses recognition, images recognition. So somebody was asking me about damaged containers, right? You could actually build a machine learning model right here, right? And not much of a code is required, right? So and there are lots of tutorials as well. So all of this will help you to quickly go ahead and build and incorporate AI into your hackathon project as well as your real world projects as such. um, uh, Please try it. I mean, that's all I would ask for, right? Please try it, and if you have questions, you could always reach us, and we're just a email away or a ping away on Teams, right? So these are several options which people wouldn't come across very easily, but then these are all things that will actually make your life very easy. And then it's exciting because everybody talks about AI, and you are the one who is now using AI without having to learn a lot of code. And next I wanted to talk about how to deploy your models, right? So somebody was asking me a question about, okay, I have data in SAP. How do I go about using my machine learning model that is built? It's super easy, right? So you could expose your machine learning model as an API, right? That is one way to do it. As long as I host my machine learning model, it's like calling a URL like google.com, right? So the API is going to accept certain parameters, which is the data, the input data that is coming from SAP, and then you score whatever predictions that you wanted to score within the API and return that particular output to wherever the call came from, right? So that is one way of using it. The other way of using it is, say, if you are using Azure in order to store the data, ML Azure Studio can sit on top of Azure, and then it can process the data that is there within Azure. So that is one way to do it. Either of the ways is possible. It's just according to your project and where the data resides, how much of a security you have on the data, how much of a control you have, how much of an access you have, decides where you wanted to deploy your machine learning model. Again, we will help you. If you need help in order to deploy your machine learning model for hackathon, please reach us out. Okay, so we have actually come to the end of our seminar today. And of course, nothing is stopping you from doing your machine learning model. If you have some Python developers on your team, or if you have somebody from AI, ML, or data science background already in your team, they could actually build the machine learning model from scratch using Python or R, Scala, or Julia, right? So the reason we encourage AI/ML models to be built internally with programming is one of the pitfalls that I see with Azure or Google Cloud Platform or H2O is until they enable certain capabilities, right? So today yoga poses. I mean, I have recently come across somebody building this particular model to automatically detect yoga poses in a yoga place, right? This kind of a model, it needs yoga poses to be defined in the database first. And unless Microsoft makes it available, we cannot go ahead and build such a model on Azure as of today. So that is one pitfall that you have. And then when you build a machine learning model, it sits on top of Azure. So everybody can see it. I mean, Microsoft definitely can see it if they wanted to, right? So, and then you don't have a lot of flexibility in terms of tweaking whatever is made available, right? It's proprietary to Microsoft. So you can't go and change a component. Whereas if I build a machine learning model internally with Python, or R or Scala or Julia or Go, you basically have complete control on the model. Where you have to deploy, what you have to deploy, when you have to refresh your model, totally is under your control. So that's one of the reasons we would encourage you to do the machine learning models internally without having to use third-party tools and paid tools. But again, for hackathon purposes, you could always go ahead and leverage these open source tools or paid tools as such to quickly build a prototype. But if you were to hire somebody in your team who's a data scientist, nothing like it, go ahead and build a model in Python, right? Or some other language that accommodates your machine learning model. Abhishek, any thoughts from your side that you think you would wanted to share with the team today?
Yeah, I think Sunil, you have covered pretty much. So yeah, unless they have any queries, definitely I think it's all that they need at least to get started.
Super.
So
I think we will open up for questions. Yeah, go ahead.
Absolutely. I was about to say the same thing. So that was awesome. Really kind of comprehensive coverage of a bunch of different techniques. I'm curious. There's loads of things there that we can do with AI. There's lots of kind of tools that are available to us. What's AI not good at? Are there any problems that it can't really solve today?
Yeah, sure. So your AI or machine learning model is as good as the as data, right? So for example, Amazon built a use case a few years ago to basically select probable resumes for a particular position. One of the things that was observed with this particular algorithm that they've built is it was a biased algorithm. So whatever women resumes were coming up for top positions like a vice president or a senior vice president, if there was a mention of a gender in that particular resume, specifically women gender, it was rejecting that, right? They identified that the training data that they've used as most suitable candidates for leadership positions, it was all filled with men, unfortunately, right? So there were not enough samples that represented good women leaders in their training data. So what AI learned from it was, only men are suitable for leadership positions. So when they deployed the model, none of the women candidates were actually picked up for interviews for leadership positions. So your Amazon had to curtail that particular model a few years ago, and Google recently it was sued, right? I mean, a woman's photograph was identified, an African woman's photograph was identified as a gorilla, because the algorithm was biased and it couldn't clearly differentiate between a human versus gorilla. In fact, we talk so much about robots, etc., right? It's funny. The computer vision algorithms today cannot differentiate between a muffin and a puppy, right? So a puppy with all the wrinkles on the skin, etc. It can't differentiate between a muffin versus a puppy as such. So that's the maturity. I mean, we're not at there where AI is going to dominate humans and all that. But there are definitely certain exciting things happening in AI. Like AI can do paintings today. AI can generate poems. AI can generate books. All of these exciting things are happening. But if you ever ask me if AI is going to dominate humans, it's never going to happen, right? At least in the near future as such. Yeah, and then AI. Yeah, Sure. And AI can be used in both the ways, right? So, for example, I know of a company that basically is an online pharmacy, right? You order medicines through this particular online app. What we think is we are getting medicines from this shop, but the way they can use your data is they could actually mine that data in order to get insights about, okay, in Bangalore, in a particular location called X, what kind of patients are there? Are they suffering from diabetes? This could be mine of information to be sold to doctors, right? So I could advise that particular doctor saying, a diabetologist saying, well, if you establish your shop around this particular location called X, then you could actually make a lot of money. I could use that for a different purpose altogether, the same data. And in fact, their AI was used and for very, very bad purposes recently, such as the same face detection algorithms or computer vision algorithms were deployed in order to identify the sexual orientation of an individual, which is nobody's business, right? And think about deploying such systems in very orthodox countries. It would lead to identification of people of different orientation and some other repercussions as such. So not a good thing as such, right? So these are some of the problems with AI: ethical problems, gender bias problems. I mean, at the end of the day, your machine learning models are as good as the data. What kind of a data that you have used in order to train the machine learning model will define the uh, purpose of that particular model and will decide the future of how useful that model is going to be. I hope that answers your question, Dave.
I think it does. Thank you. I think ethics and AI is a very complicated and big topic, right? So it's we could talk for hours on that. There's a few more questions coming in. Let's just cover them, I think, before we curtail the session. Mario was just asking about kind of Python versus Azure. I think it was answered in the chat that Python gives you, Python and kind of writing your own algorithms gives you obviously total control, but obviously more work. And then if you use one of these kind of pre-built models or kind of pre-built solutions, you get speed, but you don't necessarily get control. Sandeep is basically asking kind of what's some really good places to start. So obviously you've got Teachable Machine. Have you got any other kind of recommended sites and stuff that could be helpful to a beginner?
Sure, absolutely. Sandeep, that's a great question. In fact, if I wanted to do a particular project, right, we don't actually start from scratch. We either look for pre-trained models. This is the keyword that you need to search for: pre-trained model. Whether it is churn analysis, or whether it is identifying gender of an individual, or whether it is identifying whether this person has Parkinson's or not, I would look for pre-trained models on Google. And a lot of these researchers, basically, they write machine learning papers and then they open source their models that they've built and code. There are two popular places where you would find them. One is GitHub, and another place is Papers with Code. And what we generally do when we have to build models is we clone those repositories. We see what are the results that those repositories are giving. And if there are customizations to be done, at least I don't have to start from zero, right? I will start from a 30 mark and then try to reach the 100. So even for your hackathon, that's what I would suggest doing. Don't develop from scratch. Look for what is existing, try to reuse those.
Okay, Rohan's asked, sorry, I didn't see a question before. For continuous source of information to access data lakes, APIs are required, how to build them. I think it's more around kind of like, how do we actually get access to the data inside Maersk and what data is available?
Yeah. I mean, this is where data engineering teams comes into picture, right? So, it's good to have a data engineer as a part of your team. Because they are the ones who would who would otherwise have access to Azure, and they would be able to get you the data that you wanted. And essentially, in a data science project, because is running on a daily basis, we would establish a pipeline from the data source to the machine learning model. That way, it will consume the data. and then get the predictions and store the predictions somewhere. Or you could actually take the model to the place where data resides, and we will make it run on the data that is accumulated for a day, and then scores all the records and puts the output in a particular field in the data lake or data stage or wherever it is. So those are the options. And API hosting, of course, you can do it on an independent server. And of course, data pipelining needs to be done by your data engineering team.
Makes sense. Makes sense. Anil's asked, who owns the data in terms of ownership if you were using the free tools for AI? Is there a risk of data used? I think, Anil, the answer is absolutely yes. There's definite risk there. We should check before we push a whole bunch of MERS data into any solution, we should check deeply where and how that data is to be used and who owns that data. We shouldn't just throw data around.
Yes, of course. But most of this open source tools, they reside on your system, and you just have to pass it through the compliance team to see if it's okay to use the tool as such. This is a very commonly asked question, and there is a triage that we need to go for, right? So if I were in your position, or if I were in your shoes, what I would do is I would make sure that I basically desensitize the data for any private information, right? So for example, I would remove social security numbers, I would remove the customer names, etc., from the data, which are personally identifiable information. How do I do that? Again, it's an area of AI. I mean, I want to introduce you to another tool here called Open Pseudonymizer. Right, so basically it takes the data and it replaces the data with some other encrypted key that cannot be deciphered unless you have a pseudo key, and unless you have a key that you have used for encryption. So again, this is from University of Nottingham. Feel free to use this tool to change the formats. That way, nobody, even if they tap into your data, can decrypt. I mean, can interpret what it is. So these are, highly kept trade secrets within data science team. So you all know it now. So how we do data science even with sensitive data.
Awesome. Let's see. No. Quick question, Sunil. Is there a map anywhere? This is just for my own kind of knowledge. Is there a map anywhere of where all those kind of major data sets in Maersk live and how to get access to them? So if I wanted customer data, if I wanted invoicing data, if I wanted shipping instruction data, is there a catalog anywhere?
No, unfortunately. GCSS is one place where we get the bookings information, etc. Unfortunately, there is no such catalog. But we do have dedicated data engineers that help us to source the data. But at least that's true from a what do you call Maersk perspective. But if you are looking for open source data elsewhere, that is something which I can help with. UCI machine learning repository. If you wanted to learn data science, or if you wanted to quickly get data for your hackathon, some pseudo data, this is where I would go to, right? UCI machine learning repository, there are tons of data sets, invoice data, image data, Facebook data, etc., etc. If you're just trying to build a prototype with some pseudo data, even if I don't get Maersk data, I could go here and try to get data that is similar to that of Maersk data, and then try to build a model for demonstration purposes. Once that is successful, probably I could actually go into sourcing Maersk data, because by the time I would have anyway secured leadership's approval for this kind of a machine learning model or product that I've built. So, well, you have the blessings of leadership. Nobody will say no for procuring the data. So, but this is where I would start with.
Awesome, thank you. There's no other, I don't think there are any other open questions in the chat. So we'll close off the session there. Thank you, Sunil. Thank you, Abhishek. That was absolutely awesome. The session has been recorded. It will be, the link will be made available as soon as possible. I've got the slides already, so those will be uploaded onto the toolbox. And yeah, it's just a reminder again, it's the 20th for the final submission deadline. 23:59 GMT is the final submission deadline. So that means that if you submitted your idea to the hackathon, you need to have worked it through, really understood what that problem is, what the business problem is, who the customers are. You know, if it's an internal problem, like who are the internal customers? If it's an external problem, who are the external customers? Really deeply understand that problem and work it through, and put together your under 3-minute submission video. And there's a bunch of we've got a couple of pages just to show you kind of where to upload the session, where to upload your submission, that kind of stuff. So feel free to reach out to us, and thanks again to Sunil and Abhishek. Everybody have a lovely day.
All right. Thank you so much. Have a lovely day, everyone. Bye-bye.
Yeah,
everybody.
thanks everyone. Bye-bye.
Thank you. Bye.